Welcome to 7.4, which is properties of logs and also applications of logs. So one of the things that we need to do in order to start solving log equations is introduce a couple of their properties. Now, I have here on my notes, remember that logs are just exponents. So the properties of logs are going to mirror those of the exponents. And I've written down 4 big properties of logarithms that I want to talk about. And I actually have this extra column over here, exponent property. So each one of these properties, except for this last one we'll talk about, mirrors a exponential property. Now when we started chapter 7, I reminded you guys of the properties of exponents. That's also from unit 1. So we have the math version of all of these, and then we're also going to have the English version, and I'm going to write our exponent property down as well. All right, so the first one is log base a of xy is log base a of x plus log base a of y. Now whether you write them, this side first or that one first, it doesn't matter. How I would think of this is a sum of logs is a log of product. Okay, so sum of logs is a log of product. So really now this is how they're written in the guided notes that I gave out to you guys. I really think of them as the other way. I think of this part being written first, but again, it doesn't matter. Log base a of x plus log base a of y is log base a of xy. So if I have a sum of logs, I can rewrite it to be a log of product. In terms of exponential, remember that if I multiply matching bases, I add the exponents. So that's exactly what this property says, right? If I'm adding exponents here, because remember a logarithm is just an exponent, this log base a of x, whatever it is an exponent for a that turns it into the number x. So here I've added exponents, which means I must have been multiplying the result. Here the exponents are adding, so I was multiplying the result. Okay. Log base a of x over y is log a of x minus log a of y. So this is a difference of logs is a log of quotient. So on the right hand side, I'm subtracting exponents. And on the left-hand side, I'm dividing that result, whatever happens after I raise a to a power. So a to the x over a to the y is a to the x minus y. So that's my exponential property. I subtract the exponents. Here I am subtracting exponents. Log base a of x is an exponent. And that meant that I was dividing the exponential. So here I am dividing the result. All right, this one, log base a of x to the r is r log base a of x. So powers come out as factors. All right, and this means if I have something that's raised to a power, so remember x is some power of a, it's like 2 to the 4th. That's what x is, 2 to the 4th. Then if I raise that thing to a power again, that means I multiply powers. So this says a to the mn. No, let me rewrite it. I want to write it so that it's like the same order as the logarithm one. A to the m r is a to the m times r. So on the right, I'm multiplying exponents. R is an exponent. Log base a of x is an exponent. On the left, I'm raising something that's already been raised to a power again. Power to a power. X is some sort of power, some power of A. Raised to a power, you multiply the exponents. All right. And then the last one is actually definition of a logarithm. So a to the log base a of m equals m. Whatever log base a of m is, this thing says, I'm the power that you raise a to get m. I'm the power that you raise a to get m. So if this is log base 2 of 16, then the answer is 4, right? Because 2 to the 4th power is 16. Okay, so what if you raise 2 to that power that turns it into 16? Well, if you raise 2 to the power that makes it 16, you get 16. All right, and how we can remember this is exponential and logs are inverses. Now they do not write this number 4 as its own property in the guided notes, which is fine. Generally I don't. This is really just definition of a logarithm, like what does it mean to be a logarithm. But I do want to write it because sometimes when students see it, they get a little bit freaked out, but it's just what does it mean to be a logarithm. Okay. So the exponential properties and the logarithm properties are exactly the same. If you're adding exponents, then you must have been multiplying the base. If you're subtracting exponents, you must have been dividing the base. If you're multiplying exponents, you must have power to a power. And then the last one, exponentials and logs are inverses, so they're going to undo each other when you raise an exponential to a logarithm. Now we're going to use these properties of logarithms both to move left to right, so take one log and split it up, and right to left, so take many logs and combine them into one. One of those skills is more useful in calculus, and the other one is more useful in solving equations.